For more than 3 decades, designers throughout the world have come to rely on RF and microwave transmission line products from Microcoax. We've built our reputation on delivering reliable, high-performance, cost-effective solutions to the most challenging cable configuration problems. Microcoax delay lines, semi-rigid cable, and Utaflex flexible cables are found in platforms as diverse as phased array radars, satellites, cellular base stations, missiles, aircraft, and test equipment. In addition, Microcoax is the world's largest manufacturer of semi-rigid cable for mobile handsets. Here are just some of the reasons why we lead the way in transmission line solutions for the mobile handset marketplace. Many of our customers would like to automatically place and solder our cables onto their PCBs to take advantage of the reflow and SMT capabilities of the cable. In response to this customer need, Microcoax has investigated the challenges involved in robotic placement of our parts onto a printed circuit board. This video shows how we have achieved successful placement of our parts onto a board. At Microcoax, we are using an Adept-1 SCARA robot within an integrated work cell. A total of 3 cameras are mounted within the cell, with 2 being used for this demonstration. We will be using different generic boards during the demonstration with a variety of parts. The parts that may be placed automatically range from simple straight parts to complicated bent parts or even bonded parts. We will review in detail the special considerations that need to be addressed, but first, let's watch a part placement. Here we see 2 parts being placed sequentially onto 2 boards. Let's watch that again in detail. But first, let's review what had been done previous to the demonstration. Before the PCB enters the work cell, 4 small dabs of solder paste have been applied to the solder pads on the PCB. This was done to keep the part in a fixed position after the robot has placed the part on the board, and should be easily accomplished with your existing equipment. Here are 2 types of parts that have been successfully placed by our robot. This demonstration primarily uses the tin-plated bonded part, as Microcoax recommends tin plating for improved solderability and reduced line rejects. The robotic arm acquires a part from the part tray. The part is free to move in the part tray. The part does not have to be fixtured. Sensors can be used to verify if the part has been gripped correctly. As the robot acquires the part, the PCB is brought into the robot work area. After the board has been clamped into position, the robot can continue its sequence. Using an upward-facing camera, the computer calculates the distance from gripper center to the endpoint of the lead. This computation will be used to compensate for any movement of the part in the trays during shipping or handling. This step may also be used to verify that the part has been acquired correctly. Using a camera mounted on the robot arm, the computer will determine how the board has been oriented in its work area. This step compensates for variation in board location. The computer calculates which move to make to ensure that the part will be placed in the correct position on the board. This calculation uses data collected from vision operations, namely part placement in grippers and orientation of the PCB. After deriving the correct move, the robot places the part onto the PCB. The part is placed correctly every time, since any variation in part location and board location have been corrected for by the vision system. In order to collect placement repeatability data, an inspection step may be added to the process as shown. After placing the part, the robot-mounted camera looks at the part on the board and stores data pertaining to its location. Using this data, we have achieved a placement repeatability of 0.1 millimeters. The printed circuit board is removed from the work cell and the entire process is repeated. Here we see the actual placement of a bonded part. Note that the formed leads are all coplanar on the pads. Also, you can see the solder paste that was used to keep the part in place. We have decided to use parallel grippers instead of vacuum pickup for our parts. The diameter of our part and the absence of a suitable flat surface lends itself to using a more positive pickup method. The gripper assembly assures that the part stays grasped by the robot throughout its travel. Microcoax can supply a wide variety of part trays. Microcoax will work with you to determine the best method of shipping the parts. Our part trays will go right out of the box into your work cell. Our engineering staff will work with you to design a custom tray to meet the needs of your particular robot. This video has shown that with some special considerations, semi-rigid cable can be robotically placed onto a PCB. Microcoax hopes that we have given you some insight into how to implement this technology. If you would like any further information, please call us. We will be happy to assist you in your particular application.